make an introduction. Then
Hi, good morning, ladies and gentlemen. Today, 5th of April 2025, Saturday, we are doing this webinar on data center, the facilities and infrastructure as per IS and ISO, IEC. As you all know, we've been continuously doing webinars. This is in the first quarter. So January, February, March, we completed 8 webinars, and this April we are doing around 3 or 4 webinars on various subjects. So to introduce today's webinar is co-organized by NFE and Focus. Both NFE is very dedicated toward electrical safety. The Focus is bringing all the professionals together on one platform. I will introduce NFE, one of the fastest growing society in India. In less than 2 years, we have crossed over 2,000 members, and we have around 10 active chapters across India. So what we believe strongly, where there is electricity or where people use electricity, NFE should be there to create awareness on electrical safety. So while we say that we are one of the fastest growing, the reason is we have completed almost 39 workshops across the India. This is a physical workshop that we did across India in last 2 years. It's almost like a Bharat Yatra going from corner to corner, every corner of the city. And this year, 2025, we're doing 20 more workshops on various subjects. So if you're a member of NFE, you will be getting all the notification in your WhatsApp and emails about our activity. Why did we started this society in 2022? Is to create awareness on electrical safety. Our mission is very clear: to make every electrical installation free of accident, such as electrocution and fire due to short circuit. The mission, we shall strive to achieve our vision through getting accredited for products and personal certification, which shall focus on electrical safety by design, manufacturing, installation, and maintenance of electrical product, and installation by competent. This is the one which is missing link in this whole electrical professionals in India, is having a competent qualified manpower in electrical segment. We already started various certification program for electricians and consulting engineers and the contractors on various subject on installation. So what we do, we create awareness on electrical safety, improve skills of practicing electrical engineers, improve safety measures followed in the industry. So I would appeal, I'm sure a lot of people will be joining. I would appeal those who are not member of NFE, I would urge you to become a member of Choose Anything. We have various, I just chose 3 category. We have individual, corporate, MSME. We also have student chapter. We also have international, we have yet to kick off our international membership, which may be doing in next couple of months. And our co-partner Focus Forum of Critical Utility Service is a global platform started in 2020. So to bring all the professionals in the critical service on one platform, because it's very important to integrate all the critical services under one platform. That was the objective. So our mission is to unite existing professional society for coordinated action towards intelligent built environment, promote sustainable practice and technology integration. So there are a lot of core values of Focus that follow. And they too have various members, similarly individual, corporate, MSME. I would urge to become a Focus member too, because I'm one of the founder for both NFE and Focus. So my love is equal between Focus and NFE. And good morning once again. I'm honored to welcome you all for this important webinar on design and safety in data center. This is hosted by National Federation of Engineers for Electrical Safety, NFE in short. It gives me immense pride to bring together a panel of distinguished experts. We have experts from Australia, we have experts from Dubai, we have experts from Mumbai, Chennai, and I'm not an expert, but I'm hosting from Bangalore. So let's, we would like to hear the expertise talking on this subject called design and safety in data center. So electrical safety in data center is not just a technical requirement, it's a strategic imperative. Today's session will particularly highlight how adherence to IES standards and National Electrical Code 2023 plays pivotal role in ensuring uptime, operational continuity, and personal protection. So in NFE NEC 2023 emphasized the safety first approach with updated regulation on fire detection, power quality, emergency system, and fault tolerance. So all of which are crucial for data center environment. So I would like to introduce our speaker today. Most of you know Mr. Gopakumar, who is the president of NFE, with a strong background on electrical engineering and lifelong commitment to safety. He has been instrumental in promoting best practices and raising awareness about electrical safety standard across India. If I know him quite closely, he has done over 300 webinars in last 3.5 to 4 years, I would say, and over 15 to 20 physical seminars across the country other than the workshop. So he's a very active member, and he's been seen through almost all the webinars promoted by NFE. He's also the managing director of Cape Electric, founder and promoter of Cape Electric Private Limited, Cape Electric Power Production Private Limited, Cape LP Consultant International Private Limited. His business is led by his good, fantastic team. 90% of his time goes in drafting various standard, preaching, and he's an evangelist when it comes to electrical safety. He's an active member of ETD 20 of BIS and ETD 30 and ETD 50, and also now playing an important role in revision of National Building Code of 2016. So we are expecting the new NBC 2025 to come by end of this year. He's also a member of IEC, TC 64, TC 81, and AC 37A. So their list goes on. Because I can't have everything in this slide, I've just selected few important of that, but the list goes on of his achievement and what he practices in India. So we have the next speaker, George Matthew. He's a seasoned data center construction expert and transformational leader with 25 years of experience in project management, engineering, and business growth. Holding a BTech in electrical and communication, an MBA in project management, and multiple industry certification. He specializes in data center design, construction, and commissioning. His career includes leadership role in Huawei Tech UAE, Gulfar Engineering, and Amatron Technical Services, overseeing high-value projects across UAE, Oman, and India. With proven track record in delivering large-scale infrastructure projects up to 1.6 billion. He is also an active contributor to professional bodies like PME, IEEE, and ASHRAE. We have Rajendra Paul Singh, who has joined us from Sydney, Australia. He was one of the first members of NFE, and he continued to follow us from Australia. So Rajendra is a data center electrical design engineer with 14 years of experience in project design engineering, having a BTech and MTech in electrical engineering. He specializes in data center design, construction, and commissioning. His career as electrical design lead at Amazon Sydney involved designing, implementing, and maintaining the electrical system of a data center, ensuring compliance with industry standards and collaborating with other engineers to optimize power distribution and reliability of the data center. So we have Saeed Salim, who joined us from Mumbai. He is currently delivering data center engineering services as Associate Vice President, a leading team of architects and engineers to deliver AS plus MEP design for hyperscale data center. He is the Vice President of Controllers Group Companies. He has gained experience in complete EPC process that includes site visibility study, coordination with authority, liquid cooling PODs, master planning for data center parks, logistic planning, MEP design, commercial analysis, vendor management, negotiation with vendors, client management, design of hyperscale enterprises, customers, review of civil structure, interior design for its logical design, value engineering on consultant design. Huge experience, the kind of responsibility that is playing in control is tremendous. So, these are our panelists today. My name is Dominic. I'm host for the program today. I come from fire industry experience. I'm one of the founder of NFE along with Mr. Gopal Kumar. So I don't like to take much time. I would like to invite our first speaker and moderator, Mr. Gopal Kumar, to open this session, sir. Over to you, sir.
Thank you very much, Mr. Dominic. I think I'm audible.
Yes, sir.
The screen is also visible.
Yeah.
Let me switch off my camera for the time being.
Yeah.
Okay, so good morning, everybody. This is, I think I have to switch off now it's better. Good morning, all participants. As usual, today we started with a good participation. We already have about 144 participants. Probably now people started joining. Today our topic is on data center. And for your information, there is already an IS standard existing, which is adopted from ISO IEC standard. The standard is ISO IEC 22237. And here the standard, you can see, information technology, data center facilities and infrastructure. The standard has got 7 parts. Part 1 talks about the general principles. Part 2 talks about building construction. Part 3 power distribution. Part 4 environmental control. Part 5 telecommunication cabling infrastructure. Part 6 security system. And Part 7 management and operational information. So with 7 parts, this is the global standard. The ISO 22237 is the global standard. Of course, nations adopt these standards and probably may change the numbers. For example, in sometime in US, if you see, maybe they follow a different number. Whereas in India, it's very clear, ISO IEC 22237, because it's a 100% adoption of the standard. Once when we look into the data center or information technology, we also will be looking into some of the other ISO standards, 30134, which is also an Indian standard. ISO IEC 30134, part 1, 2, 3, 4, something like that. So these standards talk about the key performance indicators with respect to, for example, part 1, overview, general requirement, power usage, part 3, renewable energy, part 4, IT equipment, part 5, IT equipment utilization, part 6, energy reuse, part 7, cooling efficiency, part 8, carbon usage, part 9, water usage. These standards are becoming very important nowadays, because the data centers are evolving, the capacities are going up, new technologies and knowledges are coming into picture. With this small introduction, probably we can have a small question or with Mr. Rajendra, our engineer from Amazon. Mr. Rajendra, can you explain a little bit about the new technologies which is coming up in data center industry?
Yeah, yeah. So good afternoon. That is good afternoon for me, but definitely good morning for India. So in new technology, currently we are going with in India region. If I'm talking about the India region, we are short with the water supply. So we are moving for the air cooled chiller system. But what is happening in the future? That air cooled system, if we go with that, we have currently the rack capacity of 3000 or 4000, and each rack is designed for we can say 15 kilowatt. But when we move for the next power requirement, that with respect to the upcoming AI, so we are moving to I can say the water cooled system, and which is the reason is that the power requirement is keep increasing day by day, and that is 60 kilowatt in today, that the all of the, I can say, most of the client that asking. And in future, like Nvidia, they are launch the one rack of 600 kilowatt. So you can see how the industry is changing day by day with respect to the system requirement, and we have to upgrade our system and the backup system and the backbone of all the data center according to the future upcoming technologies. So that is the, I can say that how it is keep changing in short term from the last 5 year or from the last 2 year, and it will I can say in the upcoming days it will keep increasing.
Okay, thank you. Thank you, Mr. Rajendra. So you mean to say that in future, one rack will be about 600 kilowatt?
Yes, yes. So you can think about how much backup system we required for, in point of view the cooling, in point of view the power system, and the space planning, how and the water requirement for that.
Okay, okay. So optimum use of these resources are very important, and that is why these standards ISO 30134 becomes very important. The key performance indicators KPI. So it has to be very well kept. Thank you, Mr. Rajendra. Thanks for the answer. Now we move to the next one. The part one of 22237, which is a generic, which talks about the general requirements of the data center. Uh, if you look at every 22237 standard, clause 4 of the standard talks about conformance. Conformance in the sense the compliances required in this particular, the compliances required in the standard to comply to the standard. So the part one talks about how the basic it starts is the first one is business risk analysis shall be completed. Availability class shall be selected using a business risk analysis. Protection classes, then energy efficiency design process shall be applied. The design principles shall be applied. And now on the right side, what you are seeing is a typical way of designing this electrical, the entire system. So it starts with the business risk assessment. I would like to talk on or call on Mr. Salim. Mr. Salim, you'd be able to give some idea about the initial planning of the data center based on this slide.
Yeah, I think here data center play a very crucial role in terms of business viability. So when we're going to select the business risk related to data center, the first point which come into picture is it we have got the right place where we can build a data center? Point number one. Point number two is we have a right space available to build a data center. So in terms of technicality, once we able to find out the business case that involve location and the availability of a customer, this two plays a very crucial role for building a data center over the place. If you see in entire India right now, the data center hub are mainly Mumbai and Chennai. Now Hyderabad and Bangalore are also picking up. Hyderabad going to be another hub. So in terms of the business risk space, customer plays a very important role. That is what I like to highlight.
Okay, thank you. Yeah, you can continue, Mr. Salim.
Yeah. Now coming to the various protection class of data center, spaces, pathway. I think you have drawn a very nice diagram on the right side of your screen that demonstrate various spaces of data center that has got a segregation and the distribution of the various spaces. So very nicely distributed. But coming to the very important part, energy efficiency level shall be selected. Now, if you see a data center nowadays, we used to hear uh, 1 megawatt, 2 megawatt, maybe around 5 to 10 years back. Right now, data center are in a double digit, 70, 80, 100, 99, such kind of figures are coming up. So energy efficiency play a very, very important role. We have to see how we can improve the PUE. So PUE, power effective utilization, where the losses in your transformer, your distribution, and also at your cooling, that play a very, very important role. While designing data center, efficiency has to be taken care in a very, very optimized way. Now, if you see the energy class of transformers are a big transformer. Right now, the data center campuses right now going on 300 megawatt, 400 megawatt. There are large number of transformer, more than I can tell you 300, 400 transformers are there in a big campus. If you take the losses of those all transformers combined together, there's a huge volume goes into it. So we have to select very, very efficient transformer so that your losses will be minimized. Then coming to next part is your cooling. Nowadays, as Mr. Rajendra very nicely said, the rack kilowatt is going up day by day. So cooling also going to go day by day. Nowadays, the good thing is that the manufacturer of server, maybe HP or Dell, they have come up with the server which can run on the higher temperature. Earlier days, it was like 18 degrees, 20 degrees. Nowadays, people are talking about maybe 35 degrees the cold air temperature. There's a very positive approach towards the data center cooling now coming up. So more and more high rise temperature getting rise. So the cooling power consumption going down. So that is a very positive approach, going to is happening in data center industry. So energy efficiency play a very, very important role. Design process shall be applied. Design principles shall be applied. Now coming to design process, I think Gopal sir, you have got another slide which talks about the IC 22237 various design process. So I think I can take up during that.
Yes.
Yes,
Yes,
sir.
I have. I just show it. I'm just showing it.
Yeah. So it's a very good standard IC 22237, which has got categorically, highlighted the various phases of data center right from the business case to till final operation. So there are such 11 cases, 11 stages have been built in this standard. So let me take you through the complete 1 to 11 process. So here, number one, the business strategy. The owner who want to build a data center strategy has to come up with the what business case he want to build. Then the next is what objective he want to achieve. He want to be the enterprise data center. He want to be the hyperscale data center. He want to be the what kind of cooling technology he want to come up. So once he fix up the objective of data center, what he want to achieve, then the system specification come into picture. So initial 1, 2, 3 are the main business objective which customer or owner fix up in the initial phases. Once he fix up the what he want to build, then come the process of having designer on board. So once designer come on the board, based on the business objective, he build the design principle, design project, and design proposal. So it's a very high level design. What all kind of megawatt he want to build, what will the space required, what all kind of component required, what kind of cooling based on the local environment. Now, if you see, if you want to build data center in some part of Middle East, you cannot think of having the water cooled chiller. It's going to be very, very expensive. You have to go with the air cooled chiller. Suppose you are in somewhere Thailand, you have got a water availability, Southeast Asia, those countries has got a water, so you can think of the water cooled chiller. So based on the region where data center come up, design proposal will be built. Now, once the design principle is built, the designer will put that high level concept design in front of the owner. That is a step number 5. So here the all major design decision on the concept is done. What all going to be built? Like your cooling, your building capacity, your megawatt, line size, phases of the building, then the building configurations, your diesel storage, then the power substation capability. Those all major component is decided in the step number 5. Once that's done, then your functional design of the system come into picture. So once the functional design is no more than the detailed design process, but designer build the complete design of the project, and that's go to owner for the approval. So once owner see that all the design concept which was freeze in the step number 4 has been categorically done properly in the functional design, then come the approval process. Once approval done, designer will compile all the design into a tender form. I think we all are aware of the maybe your high side package, low side package, design, civil package, electrical package. Those all packages will be done, and the tender is floated into the market. That's come the step number 9. So step number 9 is basically the joint decision of owner and designer to float the contract, appoint the contractor, and get all your suppliers order fixed. So once your order fixed, then come a construction phase. We all know construction phase, material delivered, contractor appointed. He does all the construction. Once construction is done, testing, commissioning, and final, your operation is started. So I can see that the IEC 22237 very nicely detailed one has noted down all the steps from the 1 to 11 and covered all aspects of the interaction between the designer and owner. So I believe this is a very good standard which data center people has to look, and they has to get into the standard, understand what all nitty-gritty of the standard covered here. So Gopa Kumar Saab, over to you.
Yes. Thank you, Mr. Salim. Thank you, Mr. Salim. So basically, part 1 also talks about the availability class. The availability class is classified. It is classified into availability class 1, 2, 3, 4. If you look at the table 1, which is there in the 22237 part 1 of the standard, the availability class is made classified based on the power supply, power distribution, environmental control, telecommunication, and so on. So basically, it's like a kind of a reliability clause or class of tire or something. So probably Mr. George will be able to explain more on this availability clause.
Yeah, good morning, everybody. Thank you for this discussion. So, Mr. Gobakumar, it is very nicely presented here. So I don't want to read everything. So from experience point of view, without looking at the table, I may try to explain this. So there are two institutes or two standards or two organizations who's really maintaining data centers standards or tier class or availability class, which is one is TIA, which goes with the TIA 942 standard, or there is another institution called Uptime Institute. So TIA says class 1, class 2, class 3, and class 4, wherein Uptime says tier 1, tier 2, tier 3, and tier 4. So when in the case of availability, the lowest availability or lowest, it is called fault tolerant, or how the data center is protected against fault. This is what the availability. So the available power and cooling to the load is called availability, let's say. So the lowest is class 1 or tier 1, or highest is tier 4 or class 4. So class 1 is actually called a basic data center, which do not have any kind of redundancy. It will have single cooling and single power input towards the IT load or towards the entire data center. So whenever there is a break in equipment, for example, a chiller or a chiller which gives a cooling, or a fan wall unit or fan coil unit or a crack unit, a cooling equipment is failed, the data center is failed. So it is having single point failure at every point on the data center. Now coming to availability class 2 or tier 2, which comes with again single cooling or single power supply towards the load. However, the equipment at which is supplied is configured in the name of n+1. For example, I'll little bit explain what is n. For example, we let's say we have 500 kilowatt of UPS requirement, 500 kilowatt of load requirement. We can split this 500 kilowatt into 100 kilowatt into 5, or let's say 250 kilowatt into 2. So it comes total 500, where this 500 numbers, the equipment number is n. So for example, we have 500, which is 100 into 5. So the n is 100. In tier 2 or class 2, the UPS in this particular case will be 6 numbers. So 500 is n plus 1. So which will become 3 UPSs, 6 UPSs into 100 kilowatt. Or if we select 250, it becomes 2 UPS for the load and 1 for the standby. So 250 plus 250 plus 250, or 250 into 3 numbers, which is called n plus 1. So class 2 is on single path for power and cooling. However, the equipment, which is generator, chiller, then cooling equipment, a crack unit or fan wall unit, these equipments are configured with n plus 1. So when there is a failure of a chiller, we can have the standby chiller on or the plus 1 chiller on, and the system can continue. This is class 2. Now, our life is a bit easy in class 3. So class 3 is having which is called concurrently maintainable data center, which is, it is having a 2 independent path of power and cooling to the onward equipment with the n plus 1 configuration. So at load side, we will have 2 paths of power, means path A and path B from transformer onwards towards the IT load, and cooling, which will come until the fan wall unit. We will have 2 chilled water. Let's say there will be 2 chilled water pipe circuits towards the crack unit. So this is called tier 3, and equipment side, it will be configured in n plus 1 configuration. So this is called a concurrently maintainable. But remember one thing, the 2 paths, one path is live, one path is on standby. Now coming to class 4, it is fault tolerant, which is again configured on the same way with the n plus 1 configuration with the 2 independent path of power and cooling. However, both the power and cooling is live and up, So it is 100% power availability or cooling availability at a 99.97 percentage, which is fault tolerant. Anytime the data center will not be failed. Now, cost-wise, coming to us, we see class 1 is very cheap. Class 2 is class 2, class 3, class 4, or tier 1, 2, 3, 4. The maximum expensive one is class 4. In industry practice, what we are seeing normally in the industry is most of the people are going with the class 3 or tier 3. Most of the data centers, because it is concurrently maintainable, which is easy for maintaining the load without any disturbance. So I think this is having a good explanation. Thank you. Over to Mr. Kopa.
Thank you, Mr. John. Thank you for the detailed explanation. So, from the standard point of view, the ISO IEC 22237 Part 1 explains you the availability classes of the requirement, and it has got a table which explains what kind of redundancy requirements are there. For example, with respect to power supply, you have to refer to 22237 Part 3 of the standard. Here in this class 1, 2, 3, 4, the availability low, medium, high, very high. This detailed table explains you what kind of requirements are to be met in each of these clause, as Mr. Salim explained the design part. Now, every standard in this 22237, clause 4 talks about the conformance. As I said, the conformance means it is compliance. It must be whatever written in this standard or in this clause must be complied. For example, building construction, location shall have been selected following site assessment. Conformance to site conditions of class 6 of this particular standard, meet the requirement of data center space outside building, space inside the building, and it should require construction requirement as per clause 9, 10, and fire safety requirement as per clause 11. Now, if we go to each of these clause, for example, clause 9, maybe the building construction, you can find a requirement as well as a recommendation. So wherever it is written as a requirement, no compromise, they are mandatory. They are of mandatory nature. And wherever recommendations are written, of course, you can make additional, you can make it additional. For example, this one from the part 2, building construction, example with respect to electromagnetic interference. Consideration shall be given to source of electromagnetic interference. This electromagnetic interference is a very important subject with respect to electronics, because we are now living in a world environment with a lot of electromagnetics. So source of electromagnetic interference which could disrupt the effective operation of data processing, data storage and data transport. Assessment of electromagnetic environment shall be undertaken. Please note that assessment of electromagnetic environment shall be undertaken. It's a mandatory requirement. Wherever shall is written, it is mandatory. Should is a recommendation. Shall be undertaken in order to determine the need for any specific construction mitigation measures. Example, upgrading the shielding. In order to find out whether a shielding requirement is there or not, you should make an assessment. A lot of data centers in India, or at least few of the data centers in India, they started doing it. Any aspect of building construction necessary to implement the telecommunication bonding requirement of ISO IEC 30129 shall be implemented. So 30129 requirements also is mandatory. Foundation, please note that I am not reading all the requirements. There are so many requirements with respect to electrical, mechanical and other items. I am just trying to read something which I felt is convenient to me. Foundation during construction, 8.5.1. The layout of buildings, foundation and structure shall incorporate, please note, shall, not should incorporate, shall incorporate the earthing and bonding system. That means you must do the earthing and bonding in the foundation of the building. Where required as protection against lightning and electromagnetic interference, the design of the building's earthing system can vary according to the required lightning protection level and to site parameters including soil resistivity. So for protection against lightning, this particular IEC 62305 shall be applied. So these are, wherever, as I said, the shall is there, these also must be maintained. For example, based on the risk assessment regarding seismic activity, relevant measures of 3730 shall be taken into account. Similarly, raised floor access, you can also see ISO 30129 contain additional requirement in relation to management of electrostatic discharge within the construction of raised floor access. So electrostatic discharge protection is also a requirement. Sorry, it's not a requirement, but it's a recommendation. You can see here. In order to minimize the risk of electrostatic discharge to electronic equipment, floor surface should have an electrical resistance in accordance with regional and national standards. Unfortunately, there is no the standard, the national standard in India is a little bit old, but there is an IEC standard which is already in discussion in India, which gives you very clear idea how to protect electronics from electrostatic charges. Then the PVC is not recommended as a flooring material. I'm just showing you some of the examples. With respect to power distribution, part 3, which is 2237, part 1 is general, part 2 is building construction, part 3 is power distribution. The conformance requirement, the compliance requirements are power supply and distribution design solution that meet both general requirements and required availability class. The environmental control applied to the space accommodating the power supply and distribution within the premise. Approach to physical security, energy efficiency, as Mr. Salim told. The telecommunication bonding system within computer system should be as per, shall be as per, you can see here, shall be in accordance with local mesh bonding requirements of ISO 30129. Lightning protection shall be in accordance with 62305. LV power supply and distribution shall be in accordance with 60364. Local regulations, if any, that also shall be met. The availability class of power distribution infrastructure is based on required availability class of the data center. power supply infrastructure should be same or higher availability class. Now, going ahead, this particular table 1 in the 622237 part 3 explains you typical functional elements of power supply and distribution. So it's classified as power supply and power distribution. Power supply consists of primary supply, secondary supply, the transfer of the supplies and additional supplies if required. Distribution consists of primary distribution, UPS, secondary distribution, tertiary distribution, and so on. So all these, the details, example, for example, the space requirements are defined in one of the standard. Now, the sockets, finally, the equipment are connected to the final point, which is, the socket. There are the final equipments are connected to the socket. There are 4 types of sockets defined in the standard: unprotected standard, protected standard, locally protected, and short break socket. Unprotected means it is suitable for equipment that is not critical to the functioning of the data center. Example, powering of tools and equipment required for the maintenance of the facility. Protected socket is for the data equipment, intended for equipment that is critical to the function of the data center. Example, information technology and network telecommunication equipment, certain elements of environmental control and security system, and which cannot tolerate failure of supply. The socket 3, locally protected socket, intended for equipment, example, emergency lighting. This means there is a localized UPS for that particular supply, for that socket. Then short break socket. So sockets are classified into 4. These are finally the requirement. Now coming to the design part, requirement and recommendation of power supply, power distribution, and additional consideration. The power supply and power distribution requirements are explained in part. I would like to invite Mr. Rajender. Will you be able to explain more on this particular part?
Yes, 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 sir. So I see triple 237. This is very well explain the requirement of availability class, which is required for the facility and the infrastructure. And to meet that requirement of availability, that the power supply and distribution within the data center shall be designed and selected in order to provide the required availability of the power supply to the end equipment. So now the end equipment is actually the rack. We are talking about the rack. Now the availability class of supply, power supply and the distribution shall be at least equal to the required by the availability class of the overall data center. So we are going to discuss about the power supply. So power supply is nothing that it is the main power we are getting. We have to plan for the one facility or the data center from the supply authority. So that power supply, it should be designed with respect to that we can meet the availability class of the data center. So main part of that power supply is the capacity planning, how we are going to plan the capacity. So in that capacity planning, sizing, that is the key role that is play in the capacity planning. So in sizing, when we have to do the sizing for the power supply, we have to see that the maximum capacity of the power supply to the data center shall be sized to accommodate the maximum plant IT load and the future growth and the technology development, that including the increased power density of the IT equipment that is upcoming in the futures. And it is also associated with the maximum load associated with the environment control supply system and predicted external ambient temperature, humidity. And addition to that IT load, we have to take care about the load which will be required for the security, lighting, building energy control system, and the battery discharge current also. And because this campus and data center have the huge power requirement, so definitely there will be the losses also. So that should also take care during the sizing. And for the operation point of view, how we are going to initial load, what will be the day one requirement, and how the growth of active power will be over the time it will come. And during inspection, like the what load we have to connect for that, like the load bank, it will be 3 megawatt DG set, and we have to test that, and that load will be additional to for the system that will be required during, I can say, for the UPS when we are going for the bypass mode. So that have to also take care. So this type of this is the requirement for the sizing, I can say. Now the next is for the expansion. So we should also take care for the expansion which will be required during the initial load and the plan load, maximum plan load during the maintaining optimum efficiency. Okay, and with respect to diversity, if I'm talking about the availability class for 3 and 4, that is asking that duplication and diverse routing of the incoming power supply means that should be the two path from the main grid. Okay, that we have to take the two path, and from the CTT tower, I can say, and it should not mix with the each other. Okay, and now, if I'm talking about the availability of utility supply, so we should cross-check this with the utility during the, I can say, the due diligence, that what is the availability of the utility supply. It is nothing. It is a actual the reliability, how the our backup system, the backend system of the transmission power supply, it is reliable or not reliable. For that, we can check the capacity of that grid, period of use, and the load profile also. And when we go for the power quality, we should also take care the power quality. So power quality play a critical role in the data center because we are feeding to the IT rack. So for the power quality, if we are going for the power quality monitoring, it should be properly logged, analyzed, and it should be data should be collected for that according to the IC requirement. And when I move to the load present to the utility supply, so the load power factor and the harmonics present to the supply shall remain within the boundaries. Uh, it should not go beyond the IC requirement and IEEE requirement for that. So we can see the input power factor and the harmonics spectrum of the equipment which we are going to use, and how the supply we are getting, the quality of supply. And when we move for the equipment, definitely equipment, the equipment is the main power transformer from which we are going to feed the our facility or the data center. So for the transformer, we have to take care that how the transformer is designed with respect to the peak load, including the peak design ambient temperature, and where it is located, and how the load is feeding from that transformer, including the UPS and drive also, and where the transformer is located. It will be the outside of the building, and the housing should be in such a way that there should not be the risk of fire. Okay, so that the design have to take care as per IC for the OL type or dry type transformer that we are going to use. So when we move for the supply transfer switch, so that in India there is no general practice for the synchronization of the system. So we should take care that okay, the supply transfer should be automatically. It should not be manually in case of the main power failure, and we have to monitor that also. And for that we have to select the LV and HV equipment comply to our IC requirement 62271. And there should not be, because we have to go for the open transition, because in India there is no practice of the synchronization with the utility supply. So there should be the delay within the transfer when we are going to transfer the supply between one source to another source. So these are the system, and next one is for, if I'm going to talk about the UPS. So UPS should be designed with respect to the normal operation on when we are going to feed from the UPS, and when the UPS is running on the bypass mode, and the power will be fed from the utility. So that have to take care. And now, as Mr. George explained, availability class of the design option. So we have four class, which is the similar to the tier 1, tier 2, tier 3, and tier 4. So class 1 is that where we are going to feed the single part to the primary distribution equipment and with a single source. So in that, a single fault in the function element can result in the loss of functional capability. And now when we talk about the class 2, in class 2, a single path to the primary distribution equipment and with a redundant source. So in that case, a single fault in the source shall not result in the loss of functional capability of the path, and the routine plant maintenance of the source shall not require the load to be shut down. So when we move for the class 3, the class 3 is the multiple path to the primary distribution equipment and with the redundant source. So in this class 3, a fault of a functional element shall not result in loss of functional capability, and the plant maintenance shall not require the load to be shut down. In class 4, multiple path to the primary distribution equipment and with multiple sources, a fault of a functional element shall not result in the loss of functional capability, and plant maintenance shall not require the load to be shut down. So the class is 4 is the best one, but we in that we require the dual multiple path and the multiple sources. So how this is the way we have to design the power supply. So now when we move for the power supply to the power distribution, so in power supply we discussed about how we are getting the supply from the main grid or uh, the main power source to the facility. Now we move to the power distribution, where we have to distribute the power within the facility for that. So in that, first again the capacity planning of the data center. So the maximum capacity of the power distribution system and the associated space of the data center shall be sized to accommodate the maximum plant IT load and the future requirement and the technology development also. And additional load including but not restricted to the security, lighting, and UPS battery recharging that we require for during the battery discharge time. So, and next one is for the during operation time, we have to take care that initial load, what will be the day one load and the growth of active load over the time for the data center. Okay, now we move to the expansion. So the selection of functional element on the premises accommodate the data center shall provide a solution which take care into the account of initial load and the maximum plant load which is required with respect to the maintain optimized efficiency. And with respect to the power quality, we have to take care the design of power distribution system and the selection of functional element shall take into account the anticipated power quality of the relevant by consider the active power load, the apparent power load, the requirement for the power quality within the data center, and short-term inrush current of the component, because we will face low time of issues with, because there are number of transformer within the data center, and we have to take care for the this inrush current, and we can take care during the SCCS study when we are doing the SCCS study, so that we can take care. So that have to take care for the power quality. So when we move for the equipment selection, so UPS is the main component in the data center. So UPS should be designed with respect to the uh, how it is feeding to the IT rack in the normal scenario, how it will be fed during the bypass mode, so that we have to take care. And the switch care should be designed with respect to the IC requirement for the inrush current, sorry, for the fault current and the temperature we are getting at the terminal, how the connection is connected. We are going to connect with the cables, because in one data center, in the one data hall, the capacity can be go up to the 4 megawatt. So in that case, the transformer sizing, the cable sizing, it will be heat that will within the room, within the panel, it will be huge. So we have to take care for that, and we have to compile the tech test report, and the switchgear should be selected according to that. Now, when we move for the availability class design option, so it will be the same in power distribution system as we are going for the power supply. So there are four class, actually the class 1, class 2, class 3, and class 4. So as I already explained, it is the same, that with the single path first class, and the second is single path but with the redundant, and the class 3 is multiple path but with I can say the redundant source, and the fourth is multiple path but we are having the additional equipment also for that. So it will be equivalent to tier 4.
Thank you, Mr. Adi. Actually, I would like to ask a small question to Mr. Salim. Mr. Salim, what are the challenges faced during the stage as a planner of the data center? During the planning stage, especially with respect to power supply, availability of power, and distribution.
I think you picked a very right question on this slide, the challenges in the power supply. Before I go into your answering your question, I would like to highlight few case where standard give you what are the classification of class 1, 2, 3, 4, and what will be the high level single line diagram of each class. But it never tell you which class to use where. Point number one. Point number two, there are three standards globally available: IEC, tier, uptime, and the TIE 942. If you talk about TIE 942, it talks about rated 1, 2, 3, 4, uptime tier 1, 2, 3, 4, and IEC class 1, 2, 3, 4. If you see their comparison of the electrical and the cooling distribution, they almost same. I have not come a case where they talk very different to each other. Okay, point number. This is a major point where designer has to struggle which standard to follow: uptime, TIA, or IEC. Okay, point number one. Now coming to your question, what challenges does occur when you selecting the power supply? It varies from region to region. Now, if you see Mumbai, I remember in 2010, having tier 4 data center in India is almost impossible. Uptime was not ready to certify tier 4 in India because of they want dual grid supply. And there was only one grid within the India. But now it resolved where we have a tier 4 data center certification, rated 4 certification as well. So the risk of selecting utility supply vary from region to region. Okay. If you see Mumbai, it's easy to get the dual power supply. If you talk about the countries like African countries, CIS countries, or some part of South America, getting power supply reliability assessment is one of the big tasks. If you get the power reliability assessment done, that means you have a dual source from two different substation. If two different substation not possible, at least two different transformer from the same substation. That is one of the major aspect of getting the utility supply plant to your premises. Diverse route of that plant. Either it will be from the underground cables or it will be from the overhead lines. You have to make sure these lines follow a redundant path. So any mechanical failure should not hamper both the sources failure. That is the main objective of giving a diverse path. Once come into your premises, you need to check the energy part of it. How are you going to do the energy meter? You have to have a summation meter to measure the energy, dual source meter. Those all challenges you need to tackle. Most of the utility company across globe, especially in the developing countries, they don't have the dual supply in the same premises. They don't have the summation meter kind of setup. But you need to deal with that all scenario. Now coming to the distribution, I think Mr. Rajendra explained very nicely what all the challenges or what all the things there in the every class 1, class 2, class 3. So basically it be majorly driven by the customer. Okay. Now coming to which class to be selected for the distribution, if you see all major hyperscaler, they don't care about the tier 3 or tier 4. They have their own guidelines. You need to build based on their guidelines. But when it's come to enterprise customer, mainly banks, then the other gaming companies, other small enterprise customer, they mainly dependent on the standards. So either they want TIA 942 or they want uptime. IEC 22237 in India is still a very early stage. I have not come a case where IEC, some customer comes and say, I want IEC 22237. So I think IEC 22237 still has a part to tackle to be a popular within India as well as in South East Asia and Middle East. Because in this three region, I have never come a case where customer come and ask IEC 22237 compliance. So I think here the main challenge basically your designer to tackle is which standard he need to follow. So I believe Mr. Gopal Kumar, I could able to answer your question.
Yes, thank you, Mr. Sarin. Thank you very much. So it was a detailed explanation. Actually, this 22237, it is the base for TIA or probably the uptime institute. So basically, because ISO is mandatory for every WTO nation. Also, the sustainability goals are set by UN and followed, through this mechanism of ISO IEC. So actually, then if we look at part 3, it also talks about the additional requirements. Additional requirements, for example, I just put 3. These are the 3 additional requirements. Other than power supply, power distribution, the next is the residual current measurement, lightning and surge protection, segregation of power distribution cabling from information technology cabling and equipment. So these are the requirements. So also participants, please note that we are not going deep into the other part 4, 5, 6 and other parts of the standard. Now, if we look at the part 3, example of conformance, it says that the LV supply and distribution shall be in accordance with IEC 60364. And to get the compliance to 60364, for example, when we design, the details of conductors, these items which is there in this serial number 1 to 10, something like circuit length, fault loop impedance of lead conductors, in both cases resistive and reactive components shall be considered, voltage drop, short circuit or original circuit. All these subjects need to be considered when you select the conductors. Similarly, when you select the protective device, the serial number 1 to 13, nominal current rating, number of poles, long-time current, long-time delay if applicable, short-time current, short time, and the final one, current time characteristics for given setting. All these subjects are to be considered in the design if you wanted to make a compliance as per 60364, and it is written, what is written is it shall be complied. So you must consider these points. Also, the concept which is followed in 60364 is design, selection, erection, and verification. So first is the design, then selection of the equipment to be used, erection of the equipment, and finally verification. This is the sequence. If we look at the verification, which consists of inspection and testing, there are several items to be inspected. You can find this in 60364 part 6 of the standard. Method of protection against electric shock, propagation of fire to be controlled, and there are several multiple subjects to be inspected. Similarly, multiple subjects to be tested, starting with the continuity resistance of conductors, insulation resistance, floor and wall resistance, impedance test, polarity test, effectiveness of automatic disconnection of supply, effectiveness of additional protection, and so on. So basically, there is a sequence of design requirement, selection, erection requirement, and verification in the form of inspection and testing. These are actually mandatory as per ISO IEC 22237. If you look at TIA, it is the same. Only thing is, instead of 60364, they will say the design must comply to NFPA 70 or NEC of America, because TIA is the American standard, so they need the compliance as per NFPA 70, where also the requirements are similar, because electrical design basically it starts with 60364. Similarly, telecommunication bonding system, if you look at telecommunication bonding system, people always try to, a lot of customers ask to make the demand of compliance TIA 607. I just try to make a comparison what is there in 22237. For example, 22237 says telecommunication bonding system within the computer room and telecommunication space of the data center shall be in accordance with the local mesh bonding requirement of ISO 30129. I will just try to explain what exactly is this. Basically, the subject is explained in ISO IC 30129. This is about the telecommunication, finally, the bonding networks in the telecom room. Also, the subject is explained in TIA 607 E, which is the latest standard in the series of 607. But often people try to demand the compliance as per TIS 607B. 607B is old one, 2011, which is already updated or upgraded to B to D to E. So already the standard is revised. The latest one is 607 E. Now, if you look at the picture, two pictures I am showing, the left one from 607B, the right one from 607E. If you look at the some of the wordings which is used, see, for example, here, telecommunication. The old concept or the old nomenclature used in the standard was 5.2.1 within a building, telecommunication main grounding bar, bonding conducting telecommunication bonding backbone. The old nomenclature are being replaced with a little bit new names in the 607E. The telecommunication main grounding bar has been changed to primary bonding bar. Telecommunication bonding conductor for telecommunication is changed to TBC. Now, if you look at these pictures, for example, figure 2, 3, and 4, I am just showing you figure number 3. You can see here different equipment within the building are connected finally to a primary bonding bar. This primary bonding bar, it goes to the entrance facility. That means whatever the power supply which you are going from there, it goes to the grounding conductor. Basically, the standard TIA 607 says inside these telecommunication room, you have to have a bonding, as you can see in the picture. Now, if you look at the TIA, compare TIA 607E, the latest one, and the ISO 30129, the nomenclatures are same. The way of explaining in ISO is little bit different. It talks, this is the illustrative example of a telecommunication bonding network in a large building, which consists of MET for the main electrical distribution, primary bonding bar, secondary bonding bar, and so on. So basically, the contents of 30129 and the TIA are almost as Mr. Salim told, it is the same. Only the way the subjects are explained is a little bit different. But I would like to take you to a very interesting part, because every customer demand that I need compliance as per TIA 607. Now let's look a little bit deep into it and find out what exactly the TIA 607 or 30129 says. I'm just showing you the requirement, as you can see here, shall be in compliance, shall be in accordance with the local mesh bonding requirements of 30129 is what is explained in the 2237 standard. Clause number 6 of the standard explains selection of telecommunication bonding network. What the standard says is, the designer should make an assessment. Therefore, an assessment has to be made based on a balance between complexity of the telecommunication bonding network and the type of cabling media. Following this assessment, if there are financial or technical justification for an implementation other than clause 11, then the bonding network of clause 8, 9, and 10 as appropriate should be considered. So, for example, what the standard says is you must prefer the recommendations in clause 11. If you have any technical or technical or financial justification, then you can go for the recommendations in the other clauses, which is in 8, 9, and 10. I'm showing you the 9, 10 later. The assessment also, it says, any bonding approach specified in the standard is enhanced by the installation of a power distribution system conforming to TNS. So TNS system is like a mandatory requirement, in particular 60364-444. So it's very interesting to find out what exactly these standards are saying. For example, clause 11 of the standard 30129 says mesh bonded network. The mesh bonded network provide enhanced immunity to EMI compared to that provided by bonding network specified in clause 8, 9, and 10. That means 11, whatever recommended in 11 is better than 8, 9, and 10. The objective is to provide a DC resistance between adjacent point of the grid created by the mesh not greater than no more milliohm and inductance no more than 6 microhenry. Then it is classified into local mesh bonding network, which is called as local mesh IBN. Mesh IBN is typically limited. Why I am showing this is you look at on the left side where I am moving the cursor, the 22237 says the minimum requirement of telecommunication bonding is shall be in accordance with local mesh bonding. So local mesh bonding is called as mesh IBN, is typically limited to a restricted area within a building, such as areas of concentration of IT equipment. That means it's for a smaller building, smaller room with data centers. Whereas for a larger building, what is required is mesh BN. As you can see in the picture, the entire building is made in such a way that the entire exposed extraneous conductive parts are connected in such a way that all the requirement of telecommunication bonding are met within the building. This is the mandatory requirement not only in the ISO's IEC standard, it is also a requirement in the TIA standard. No compromise. It is a mandatory. However, from where this comes, the IEC standard 61,000 explains that putting this separate earth electrodes in soil, clean earth, power earth, lightning rod, what is recommended? It is not recommended and maybe forbidden in some countries. This approach is not suitable for EMC and is a safety hazard. In fact, regulatory code prohibit this practice in some countries. That means this putting separate earth electrode is a violation of the standard. Even if you are interpreting everything under the soil, yes, it's a violation. Now, Mr. Salim, yes.
Yeah.
You have any comments on this?
Yeah. Just a discussion, if you could remember a few years back when we started the discussion, clean and dedicated and the dirty earthing, this all. If you could remember, we had a conversation where Karan doesn't know he is dirty or he clean. He only know where is the ground path.
Yes. Yeah. So basically, the requirement, it is a demand, it is a compliance requirement in the standard not to have separate earth electrode in soil. If you put separate, actually it's a violation of this entire standard, either it is TIA or ISO IEC or the upcoming institute or whatever. I'm just showing you one of the picture which I received recently. This is from the data center. You can see 500 square millimeters XLP aluminum cable going to earth pit 1, 2, 3, 4 up to 25 on the left side, another 25 on the right side. Now, if you look at each of these part, it goes to some parts of the building, and like 1, 2 numbers go to the body of transformer number 1, another 2 goes to the body of transformer number 2. If you look at the entire building, there are so many earth electrodes installed in the building, which is actually, it's a very clear violation of the standard, either TIA or ISO or whatever. Now I have a question to Mr. Salim. Mr. Salim, as you rightly said, we had long discussion on the subject. Of course, controllers, very well implemented without, these earth electrodes. So many buildings you have already implemented, but how others are getting, because I'm seeing lot of drawings which with 100, 200, 300 earth electrodes in soil. How these data center companies are getting approval from institutes like Uptime? Because it's a violation.
I completely agree with you. It's a lack of awareness, basically. If you see this earthing market, especially driven by vendor, you used to hear the words like ground enhancing, more earthing, then the high earthing, then the so many words they use for do the marketing. And these are the vendor who was going here and there and explaining these people. And unfortunately, our electrical engineer, if you see their academics, they talk power system, they study so many things, but as a earthing, I don't think it's a detailed subject in our academics. That is the one of the major aspect. I think the lack of awareness. But I'm happy that you took this charge from last 5 to 7 years. I am seeing you are explaining everybody that these all integrated earthing, two body, two neutral, dirty earthing, clean earthing, then the lightning protection earthing. There is nothing which has justified in any of the standard. If you see IS 3043 was written around 40 years back. Even 40 years back, these things are not there. So it's a lack of awareness, lack of knowledge is all created, is all nonsense in the market. But as you said, in our data center, we have got equipotential bonding where all the equipment, all the critical equipment connected to the equipotential bonding rods, and that's how we tackle all those issues. And one of the very good part of the standard is earlier, if you could remember, we used to calculate touch and step potential for every earthing. But nowadays standards are very clearly specified. You don't need to do for every. So I think the awareness is increasing. Such seminars are basically helping people to get more awareness about the what earthing required, and this will definitely going to have a very positive result. And this all earthpits business will definitely going to go down in next coming years. So that is my expectation.
Thank you, Mr. Salim. Thank you, Mr. Salim. Over to Mr. George. You may be able to explain a little bit about what is how the things are done in Middle East countries, Middle East nations.
Yeah, this is what I want to tell you. Am I audible? It's okay. Yeah.
Yes, you are on.
Okay. So
You can switch on the video.
Yeah. Sorry. So when we had the first discussion, I was surprised to see that you made a cross against clean earth and machine earth and all these, which is surprising to me when we had the first discussion. So though it is in line with the standard, still in Middle East and Central Asia and a few of the African countries, they are still following exactly this one. So people are still following, and we are talking to various clients and various consultants to correct this, and it is still a surprise to them. And the feeling of the market is like they are doing it for ages and they don't want to change it. So slowly, Mr. Gopumar, with your effort.
Yeah. Hello, Mr. George. I think you got disconnected.
To manage this with now. Hello.
Your voice in between, but it's clear.
Okay. So sorry, I have little bit of network issue. So is it okay now?
Yeah, it's okay.
Okay. So in the Middle East, still people are following all these old age practice, which is not in standard, which is not in line with the standard. I think I have shared a few drawings with the very latest data centers, which is again following the same thing. So we have a great effort to put into place that this needs to be corrected. Number one. Number two, for all the audience, I think, as Mr. Salim said, this is a very low priority subject, whether in academics or in the design or in the implementation practice. Earthing and protection. Earthing protection. People says that it is earthing is just earthing. So it is having a very big significance in terms of reliability, in terms of protection, in terms of fire hazard. To me, my personal experience is I had multiple fire hazards. When we have a fire hazard, going behind the fire hazard and conducting a survey, we will not be able to really find out what is the cause of fire. But believe me, in data centers, once the fire happened, it is a disaster. So I had multiple incidents where lithium batteries got fired, and this fire was unmanageable. And this time, most of the cases, I strongly believe that there is no foolproof evidence that we can say it is because of earthing. But I think most of the cases it is earthing. So this is a very, very big, interesting subject, and we need to take care of it.
Yes, thank you, Mr. George. Mr. Rajinder, you have any points to to explain, because Rajendra was fighting to make, as per the standard in several projects, but he
Yeah,
got a lot of firing from
yeah.
from.
So I want to explain the actual problem start from the consultant side. Okay, so in consultant side, the person who is doing the design, he's not aware about the how the ground fault will follow. Their thinking is that the ground fault will follow and it will get dissipate into the earth. This was the statement that when I asked that how the ground fault will follow and how the path will, because your p conductor should be connected with the neutral, and they are thinking that if we will connect the p conductor with neutral, it will get blast. Their thinking is that we should not connect the neutral and the PE conductor. So that is the reason they are thinking that. And the second is when we ask for the code, on what basis you are thinking that you are complying the TNS system, then they are saying that okay, in IS 3043 the PIT is mentioned, so that is the reason we are considering PIT. But when we ask for that how the ground fault will follow, then they are saying that yes, the current first go to the PE conductor, then it will go to the soil, and then it will come back. Some of saying that it will come back, and some are saying that no, it will get dissipate within the soil. So this is the challenge we are facing from the consultant side actually, and their assumption is that if we will connect the p with neutral, then something wrong will happen with the conductor. So the problem is that uh, they are designing the p conductor with higher fault current, but they are not aware about how the breaker will work in case of ground fault, how the loop impedance will work, and the problem start from the calculation actually. No one in India is doing the for loop impedance calculation from the consultant side. So when they will do that, then they can see what is the actual problem. And when we ask for that, okay, you are saying the TNS system and you are making the TNS system, and with the two pit for the neutral and two pit for the LV body, and we ask how the TT system will be, you have to if we ask for the TT and how the system will be designed, then they said that oh, they get confused. No, we don't know how the TT, but our system is TNS, and they are giving confirmation on that. So this is the challenge we are facing actually.
Yes, thank you, Mr. Rajendra. Actually, my question is, you see, I have seen data centers in Europe, in several nations, especially in Europe, also in India, and almost all the data centers in India has got this non-compliance. Now the question
Yeah,
is, how the auditors, those who are auditing as per these compliances, how are they accepting it? How are they, giving the certificates? Anyway, it's a big subject for further discussion. So
I think
please.
this is happening only in India, not in other region. If I'm talking about the Sydney, we have the TNS system, and then we are doing we are calculating the loop impedance, and we are connecting this P with the neutral, and everything we are doing that. But in India, that IS 3043, that one line which is asking for the pit, that is main the point of start where the consultant asks that the pit is required, because they are doing the commercial and the same guy who's doing the data center. Now they are thinking that the facility which is for the government means the transformer have the dedicated pit on the end of the service, and there is no dedicated PE conductor. So they are following the same for the commercial and the data center, even they are going with the dedicated PE conductor.
Okay, okay. Thank you. We have some questions in the Q&A. Probably I will take the questions one by one, and probably one of you can answer this. Maybe Mr. Salim. There is a question from Mr. Prasad Patnaik. What is the time duration for each phase of design phase and in a hyperscale data center?
Um, it varies from case to case basis. If you have a big data center, maybe in the 100 megawatt category, so design phase generally last up to 6 months because the volume is very high. And if you have a small data center, maybe around 10, 12 megawatt, it generally take 3 to 4 months. So it's very based on the size of the data center. That's about the India timeline.
Okay, thank you. So, Mr. Anil Kumar Solanki is asking what kind of test compliance requirement for EMI MC compliance. Okay, there are so many, several compliances are there, starting with measurements, then some items are to be included in the design, and finally, after the implementation, testings are also required. So we conducted a test with a kind of a EMI, measurement system, as well as a system which produces EMI. Then the shielding effectiveness of the building, shielding effectiveness of the trunking system, they are very well measured. There is a question from Mr. Azim Rizvi. What are the shall mandatory guidelines for passive fire protection of transformer housing enclosure in terms of compartmentalization and the firewalls provision between transformer for data centers? Can anyone can answer this question? What are the mandatory requirements of passive fire protection of transformer housing enclosure in terms of compartmentalization is required? Mr. Salim probably able to, or
Yes,
Mr. George?
Salim can answer. Yeah.
Okay.
I can answer it for the practice in Middle East, wherein there are two types of transformers we use. One is open transformer. There is no compartmentalization. If the data set, then we have another type is dry transformer, which is inside the building, which is primarily goes with the national the fire code, local country fire code. So 90 minutes to 1.2 minutes, 120 minutes fire rated wall is required between transformer and other isolation, any wall requirement. I don't remember the standard, but this is what is followed. Maybe Mr. Salim can put little bit more into this.
Thank you, Mr. George. I think here we need to understand the kind of transformers goes into data center nowadays. So there are the EHV transformer that's around 220 kV or 400 kV or 110 kV. For those big transformer, NIFPS, nitrogen injection fire protection system, is required. It's a dedicated system for all transformers. And these transformers are mainly oil-cooled transformers. So all the norms which are there for any substation across India governed by the utility companies, those are applicable to these transformers. Now coming to other transformer, in India mainly we have got the 2500 kVA as a module size. So transformer follows the same size. For this, either you have got the oil-cooled transformer or the air-cooled transformer. So in air-cooled transformer, you've got the dry type transformer, basically the air-cooled. So in this transformer, those are placed inside the building. And we have to understand in data center, the purpose of fire extinguisher is to prevent the spread of fire rather than the quenching it. That is one of the major aspects. So all the transformer area for dry type are covered with the pre-action system along with your portable fire extinguisher. Now coming to the oil-cooled transformer, they are outside the building and they're exposed to environment, and those are mainly protected by the portable fire extinguisher. So these are the main fire suppression system used for different type of transformer in data center industry. Hope I'm able to answer your question.
Yes. Thank you, Mr. Salim. But there is a specific standard in the 2237. But if we go into detail of it, it takes a lot of time. Probably we can make a session exclusively on that, maybe on a later date. So now there is a question from Mr. Gaurav Sharma. We designed and built data center with a high capacity, for example, 4.5 megawatt per floor, but customer will not add the load on day one. So we faced a leading power factor due to high side infra. That means a big infrastructure and less load. What is the solution for that? So any of you can answer, probably Mr. Salim again.
I think this is a very, very common problem in every data center, because we have to understand the fact there are two different thoughts which are involved in data center industry. One is the MEP engineer who design the power to the racks, and there is another called IT engineer who design the servers. Okay. So initially, based on the customer requirement, the IT engineer or maybe the software engineer suggests the server rack capacity, those all. And initially, when they plan and they implement the all servers, their load will be very low, not more than 10 or 20%. So it's a very, very common problem in data center. You will face a leading power factor. For that issue, you have got the UPS mainly feeding those. UPS got a capacitor as well as the inductor. So you have to lower down the capacitor size. It will be avoiding those all leading bar factor. It happens generally. But nowadays, if you see most of the racks which are manufactured by HP or Dell, the harmonic issue and power factor issue is almost gone now, almost gone. In past 5 to 10 years, these issues were predominant. Nowadays, it's a very, very low.
Okay. Okay. Thank you, Mr. Salim. The next question from Mr. Gaurav Sharma. Impedance testing of batteries, is it applicable on lithium-ion batteries? Probably Mr. George, you explained about batteries.
Yeah, the impedance testing at site level, I don't think we are doing it. No, it is done at the factory level.
Okay. Okay.
So once a factory test is done as part of this, and batteries are available at site, that's it. Then UPS will go with the reliability test with the battery.
Okay. Thank you. Sanjeev Kumar is asking about what type of power transformer, but it's already answered by Mr. Salim during the answering of the fire requirement. There is a question from Mr. Ashok Kumar. It conclude that common earth grid is recommended for data center? Sorry, Mr. Ashok Kumar, it is not like common earth grid. It is a mesh BN. Mesh BN is a different concept. The entire structure is your earth. So, Mr. Jigish Shah, whether rice flooring is mandatory as per standard for 7-story office building, office server room? Probably Mr. Rajendra, you will be able to answer this. Mr. Jigish Shah is asking whether raised floor is required for a office server room.
Yeah, actually for the office, because that is that is depend on the how the rack is feeding. So in the I can say the hyperscale data center, there is no raised floor power, and the telecommunication is happening. But for the small server room, yeah, it can be for the raised floor. But in multi-story hyperscale, there is no raised floor.
Okay, thank you. So, Mr. Srinivasalu is asking what is the transformer efficiency level 3 or K series transformer, harmonic mitigation transformer? What is the transformer efficiency which is used? So, Rajendra, any idea? You can answer this one? What kind of, how efficient are these transformers?
So we actually, the transformer efficiency in India, we follow this ECBC, and if ECBC losses is we are not complying, then we can go with EU guideline also, because that have the lower losses even from the ECBC.
Okay, thank you. So we also have a few more questions, especially IEC 22237 fire protection system required for DC and illumination system of data center. Yes, of course, almost all requirements are covered in the standard. There are a few more questions, and of course, in every program, we will have a lot of questions. And if we try to answer all the questions, then it will be, a hectic task. So we already passed. Generally, we try to limit the presentation to something about, 1 hour 30 minutes. And generally, some customers used to ask some questions. Now, Mr. Senthilnathan has asked his hand. Probably. COW. Mr. Senthilnathan, do you have any question? You have raised your hand. If there is no, Madam Pallavi, Madam, if you have any points to talk, please make it.
Yeah. Basically, can you hear me?
Yes.
Yeah. What are the key factors to be considered in terms of electrical safety aspect for data center designing in Mumbai, considering its extreme humid climate scenario?
Yeah. Okay, thank you. Now we have also Mr. Gaurav Sharma. Mr. Gaurav Sharma, if you have any points.
Yes, I put a question in Q&A again, a last question, please, if you can consider for that. Well, it will be great, Mr. Gopa.
Okay, the question is only fire suppression is required for lithium-ion batteries, and we need to plan for some water system as well, because there will be a chance of a reignition of fire in the lithium-ion battery. Okay, you are answering the question. Thank you very much, Mr. Gaurav. You have answered. You wanted to answer the question. Am I correct?
No. See, I just wanted to clarify in which clause or in which IS standard we need to put water system. It is mandatory
Yeah.
in India, or we are in discussion with industries, or what?
I think and I can answer this because water mist system is recommended for lithium ion battery safety protection. It is. I have some background noise. Yeah.
You are the
So that means it is mandatory, George.
It is a best practice. It is not mandatory because I told in the presentation that there are multiple cases of fire incident with lithium ion. You are exactly right. We have when a lithium ion battery when it reaches to thermal runaway, nobody can save the battery. It will go. It
Correct.
will go to fire.
Exactly.
So, and we
Exactly.
have exactly 8 minutes to reach thermal runaway. The moment the battery starts heating up, we have to limit the temperature within 8 minutes. So, by my experience and I have done a lot of research against this. There is no way we can save the battery. The moment thermal runaway happens, water has to be put into the battery. There is no other way. So. Where people are thinking about water mist system, maybe Mr. Salim can put a little more on design aspect. However, water mist system is being implemented everywhere across the industry as a best practice.
Sir, here
Apart from
in India also,
Yeah.
most of the places we use the water mist, high pressure,
Yeah.
low pressure water mist only used in our clean agent that is being used. On the battery, the recommendation is about the water mist only.
Yeah.
To put
Salim
more
will be
light
better.
over here, I think we have to understand one fact about the water mist: the high cost. Then the steel piping, and data center being a very, very cost sensitive market. So safety, economy, and the business has to be a balanced. So generally, what we do in data center, we put the pre-action system, as Mr. Gopal Kumar rightly said. The lithium-ion battery has got the feature of reigniting. So you might be having a case where everything is quenched, and maybe next hour again there is some battery explode. So pre-action is one of the economical and the good solution in the battery room to avoid the fire due to the reignition.
Okay, thank you, Mr. Salim. Probably, it's time to make a conclusion. Probably one by one, if we have any points to conclude, Mr. George, maybe you can make a conclusion. About the standard. What is your feeling about the standard? Whether this kind of 22237 standard need to be followed in the places where you are working and your experience, or do you?
Thank you. Yeah. So, of course, all the standards to be followed. However, the deviations are acceptable, not acceptable, which is again, as Mr. Salim said, the designer is not aware of it, the standards which is being updated. Second challenge what we have is the authorities, local authorities in every country, they take a lot of time to update their requirements and standards. So we are putting our efforts to correct all these, and industry will continue to be. And of course, there is a room for improvement for every now and then. So I hope that but we make data centers and other installations which is more safe. And engineers are builders; they are not destroyers. Thank you very much.
Thank you, Mr. George. Thank you. Mr. Rajender, you have the final conclusions. Also, comment about the standard. Mr. Rajender, you are on mute. Okay. Mr. Salim, your conclusion about the program.
Thank you, Mr. Gopakumar. Very good session. I believe data center industry is developing at its pace, and we all know data center going to be big in India. I already heard the announcement about a trillion megawatt. So a very good initiative we have took, especially for the data center designer to understand what standard says and what are topics which are generally neglected. So you tried very hard and very effectively to cover those topics. And I'm happy to part of such session again and again to be a part of a learner. And thank you for your effort and always wish you best of luck.
Thank you, Mr. Salim. I think Mr. Rajendra is not there. So, in fact, there were some more questions about the final conclusion. I think the auditors, those who are going to certify, like this Uptime Institute or whatever, they also should read the standard and they also should find out the requirements deep into the standard before making conclusions. So we will be again back with probably another subject next week. Over to you, Mr. Dominic. You have to unmute. You have to unmute.
Yes, sir. It's a wonderful session. We had total 630 registration coming in for this, and we have almost 230 attendance so far. And I could see a lot of congratulatory messages coming in with regard to the quality of the speaker that we have chosen. So while we conclude this session, I would urge you to join for the next session. We are talking about panel distribution panel on electrical distribution. We look forward to see you, and we'll be talking about the standard and say regulations. And finally, I appeal to all of you to become a member of NFE, and it's just a 1,750 rupees is a membership fee. So those who are yet to become a member, please do become, because we have a lot of information available in our website that is given only to the members. All our webinars recordings are available, and a lot of guidelines that we have released that is also available in our website. And these are informations that are only to members. So I appeal everyone to become a member of NFE. Thank you so much. You have a wonderful day, and we look forward to see you next week. Thank you so much. Thank you all the speakers for taking up time. Thank you, Mr. Rajendra, to join us from Sydney. I know it must be around 7:30 there. And thank you, George, to join from Dubai. And thank you, Salim, from joining from Mumbai. Thank you, sir. Look forward to see you again. Bye-bye. Good day.